Today we're going to talk about merge sort. The basic idea behind merge sort is taking your original array and splitting it in half, and then sorting those halves, doing that recursively until you're just sorting individual elements, and then bringing those halves back together. The benefit of merge sort over another algorithm such as quicksort is that merge sort always has the efficiency of n log n. Even in the worst case, no matter what your data is, in the best case, always n log n. The downside to merge sort is that it does require a little bit of extra storage space. I find merge sort pretty easy to understand just thinking about the algorithm intuitively, but the code can be a little bit intimidating, so I hope that this JavaScript solution will be clean and easy to understand. Again, this is a recursive solution. So we're going to need two functions. One is going to be the merge sort function. This is where we're going to find the midpoint, split the array in half, do this recursively until we get down to just one element. And then we also need this merge arrays function to merge the arrays. So let's start by finding the midpoint. I'm going to have a variable called middle, and that's just going to be the length of the array over 2. Then what's our base case? So once we get down to just one element, that's when we want to start merging the arrays and calling this function. So our base case for recursion is going to be if the array.length is less than 2. So when we get down to 1, we want to just return the array. Great. So now, using our midpoint, let's calculate a left half of the array and a right half of the array. So the left half is just going to be array.splice 0 to the midpoint. Then, since splice is going to change the original array to just be the right half, we don't need to do anything fancy. We can just set right equal to the array itself because the right half is what's going to be left over after calling splice from 0 to the middle there. So then what we want to do is call merge arrays. This is what we end up wanting to return on the left half and on the right half. But remember, we want this to happen recursively. We want to keep splitting until we get down to array length of 1, and then we start the sorting. So into merge arrays, we're going to pass merge sort of the left and merge sort of the right. Great, so once we go all the way down to having just one element and this first gets called, or merge arrays first gets called, what do we need to do inside that function? In the merge arrays function is basically where we're going to keep track of what we're ultimately going to return. When we enter into the merge arrays function, it's either going to be the first time and we're just going to have one element. We're just sorting one element and one element, the left one element, the right one element, or we're already higher up the stack of calls and we have two sorted arrays that we're merging together. So the beauty of this method is that we know the arrays are sorted and we can just look at the first element of each array and then we're going to pop off that element and put them in order comparing the left and the right. So first let's create an array to return. I'm just going to call it final and initialize it to an empty array. Then we want to go through the lists. One of them is going to be exhausted first, and we don't know which one that is, but we don't really care. We just want to keep iterating and comparing while either the left or the right has a length. So let's do while left.length and while right.length. So when either one of them is exhausted, we'll kick out of this while loop. Then from here, what we want to do is we want to check if the left element at position 0 is less than the right element at position 0. we want to pop off that element and add it to our stack. So, or sorry, our array final. So final dot push, and then we're gonna push left dot shift. So that's going to return the first element and remove it from the array left. If left is not greater than right, we want to put the first element from the right list. So we're going to do this, but instead of shifting off the left array, we're going to shift from the right array, just like that. And then what do we want to return? Well, we don't want to just return final because, for example, we might exhaust the left array, but there still might be sorted elements in the right array that we want to push onto final. So I'm just going to use the spread operator and first put the final array and then just the left, just the right. Remember, left and right can't both have elements in them, so it doesn't really matter which order you put them in. We're just using, the spread array to combine these, one of which will be empty. Great, so that's what we're going to return. Let's go down here. I have the example from earlier, and so let's see if we end up with what we expect running this. Great, that looks sorted. Okay, so just to quickly reference back to our example here, when we call merge sort, that's when we're doing these splits here till we get to one element. And then when we call merge arrays, we're doing these merges here. So merging -4 and 7, and then merging 2 and -4 and 7, those two arrays, and then doing that on the left, doing that on the right, and then bringing these two arrays together at the end. So leveraging the smaller sorted arrays to more easily sort the whole array. That's merge sort.